Hello everyone, this video is about trigonometric uh, pure mathematics 3 past paper questions. First example, we have show that proving trigonometric identity. We start from the left side, and we use the sine double angle for the sine 2x here. We use this, and cos double angle. We want to get rid of the 1 minus here, so we use 1 minus 2 cos squared x minus 1 because minus times minus 1 we get plus 1 and we can cancel out, and at the same time we factor out 2 sine x, and after we cancel out 1, actually we don't cancel out here, so 1 plus 1, so we have 2 minus 2 cos squared x. We don't cancel out, but we can factor out the 2 here. We can cancel out the 2, and we have only 1 minus cos squared, and we use the difference of two squares algebraic identity. We have 1 plus 1 minus. Now we can cancel out, and we have what we need to prove. Next example, by expanding cos 2x plus x, show that, and then solve. Okay, so cos 3x equals cos 2x plus x, using cos compound angle, cos minus sine, and then we use the double angle cos, because we need to get something in cos. We use the 2 cos squared minus 1, and this is sine 2x. We use the double angle sine. We have 2 sine cos, and we multiply 2 cos squared times cos, 2 cos cubed, minus 1 times cos minus cos, and sine times sine squared. We use the Pythagorean. Sine squared is equal to 1 minus cos squared, and we multiply by minus 2 by minus 2, minus 2 cos x plus 2 cos cubed x, and we multiply by x, of course, and simplify 2 cos cubed plus 2 cos cubed, 4, minus 1 minus 2 minus 3. Now we solve this. We have cos 3x, and we know that cos 3x is equal to this from the first step, so we have this cos 3x replaced by this in red. We can cancel out the 3 cos x. We have only 4 cos cubed x. Move the 1 to the right, minus 1, divide by 4, take the cube root, and of course this is something negative, so for the base angle we use inverse cos the positive, so just 1/4. We don't use the negative. Now the quadrant 2 here is because this is something negative, and the x is between 0 and pi, so it's either quadrant 1 or quadrant 2. Because the cos value must be negative, it's gotta be quadrant 2. Quadrant 2 calculation is 180 minus the base angle, or in radians pi minus the base angle. So pi minus this base angle, we get 2.25. Here we expand sine cube, so this is almost exactly the same. Let's skip this, and now this is let's do this one. So we have by expanding cos squared plus sine squared, which is actually 1, so cos squared plus sine squared cubed. So here we use a plus b all cubed, which is a cubed plus 3a squared b plus, from here we use this algebraic identity, and then we can, this is still the same. This is when we move this here, and from these two terms we can factor out 3 cos squared sine squared. We have cos squared from here, sine squared from here, and this is actually 1. And we want to use the double angle, so we make it 4 times cos squared sine squared. So of course we multiply by 4, divide by 4, not changing anything, and this is actually 2 cosine squared, which is equal to sine 2x. So we have sine squared 2x, and after we move this to the left, we get 1 minus 3/4 sine squared 2x equals this, which is what we need to prove. And for the part B, solve this equals 2/3. We know that this is equal to this. We know that from this first part. So we replace with the answer to the first part, and then we do -1 both sides, and times -4/3 both sides, and we take the square root. We have plus minus 2/3. So we use the plus and the minus. For the base angle, we use inverse sine the positive 2/3, and we can use quadrant 1, 2, 3, 4 because of the domain. It says in the question domain is for x between 0 and 180 degrees, but we're not dealing with x, we're dealing with 2x, so we adjust the domain, multiplied by 2. So we can use quadrant 1, 2, 3, 4 because it's from 0 to 260, the plus and the minus. So we use everything from the calculator work, we get this. And this means that 2x is equal to quadrant 1, quadrant 2, quadrant 3, quadrant 4. And of course, we still have to divide by 2, so we get the final answer. Alright, I guess that's enough. That's it. I'll see you again next time.